Okay, our next topic is what we call the lateral earth pressure. So proper design and construction of retaining wall, such as retaining walls, basement tunnels, braced excavation, and bulkheads requires an in-depth understanding of the lateral forces that act between the retaining structure and the soil masses being retained. These structures are commonly encountered in foundation engineering as they support slopes of earth masses. So what is lateral earth pressure? Lateral earth pressure are the pressure that acts on the side of the structure or behind our retaining walls. So basically, lateral earth pressure is the pressure that soil exerts in the horizontal direction. So, okay, we have here an example of structural that have lateral earth pressure. So, we have here a retaining wall. Meron tayong soil dito. This soil will cause pressure towards our structure here. So, magkakaroon tayo ng lateral earth pressure. We also have here this one. We have both soils on both sides of our brace excavation that will cause lateral pressure dito sa ating structures. And meron din tayo ditong example for brace anchored sheet pile that both also have lateral earth pressure acting upon them since we have soil that will cause stresses in our structure. So lateral earth pressure actually is important because it affects the consolidation behavior or and the strength of our soil. So, pag pinag-uusapan natin yung lateral earth pressure, pag-uusapan din natin yung Runtime earth pressure theory. Okay? So, the Runtime theory assumes that there is no wall friction. The ground and failure surfaces are straight planes and that the resultant force acts parallel to the backfill of the slope. In case of retaining structures, the earth retained may be filled up earth or natural soil. So these backfill materials may exert certain lateral pressure on the wall. So yung soil natin, nag-exert siya ng pressure and yung pressure natin dyan is magkakaroon tayo ng lateral earth pressure doon sa ating structure or wall. So a lot of different roles that lateral stresses in soil play. And lateral soil stresses are very important, mostly because they provide a lot of resistance. And so if we don't want something to move, we often restrain it. Ba? There's a different types of way that soil resistance or the soil loading can play with the lateral earth pressure. So we take this, we have here the at rest lateral earth pressure. So the wall is restrained and not moving. Pag sinabi naman nating active soil pressure, yung lateral pressure exerted by the soil that causes a slight movement of wall away from our retained soil materials. And pag sinabi nating passive soil pressure, our lateral earth pressure exerted by the soil by moving the wall slightly towards our retained soil materials. So we have here an example of rigid. So yung naka-at-rest lang tayo. At-rest. Wala tayong anchored pile. Hindi natin gagalawin yung ating soil. So we have here a condition wherein if there's no loading going on, we have no stresses. So we just have or we have just a soil all by itself sitting, we call that at rest condition. Say if the wall is rigid and does not move with the pressure exerted on the wall, the soil behind the wall will be in the state of elastic equilibrium. Kaya at rest pa rin yung ating condition dito. So, we have at rest lateral earth pressure. Okay? So, now if we have a retaining wall, you can imagine this. Okay? That the soil behind, ito yung retaining wall natin, and then the soil behind our retaining wall compresses or it moves. So, basically, the soil movement is this slope. So, ito yung movement ng slope natin. This movement of our soil will cause our retaining wall to move away doon sa ating backfill. So, this is now the movement of our retaining wall structure. Okay? We also have here the passive. Say the soil behind our wall, if I rotate that wall into the soil or if I move that wall enough into the soil, what happens is that it's going to cause the soil to fill in that manner. So, ito yung ating slope. Ito. Okay? Behind the wall, and what happened is that we will be having our retaining wall that is trying to move into our soil. So, yung condition na yan is passive condition. So, pag sinabi nating passive condition, yung wall, nagmo-move siya toward doon sa ating soil materials. And pag sinabi nating active, yung ating movement ng ating wall or our retaining wall is away from our soil. And pag at rest, the wall is restrained and not moving. Okay, so that is the types of lateral earth pressure. We have three: at rest, active, and then the passive. So we have here the value of K, our coefficient of lateral earth pressure. So K varies depending on the type of the horizontal loading that is going on. So is the soil at rest? Or say, is the soil active? Or is the soil passive? Is the soil passive? So the coefficient of lateral earth pressure depends on the type of loading ng ating soil. Okay? So, if we're dealing where the wall is being pushed into the soil and causing the soil to compress. So, di ba, pag pinupush ng retaining wall natin yung soil, magkukompress yung soil natin. And that is what we call the passive condition. And yung coefficient of lateral earth pressure natin is denoted by K sub P. So, K sub P, this is our passive earth pressure coefficient. And if we're dealing naman, if the wall is rotating away or sliding away from the soil, then that is active condition. And yung coefficient of lateral earth pressure natin, K, is denoted by K sub A pag active condition. This K sub A is now our active earth pressure coefficient. Okay? And if everything is at rest and nothing is moving relative to each other, we denote our coefficient of lateral earth pressure K as K sub O. So that will represent that our earth pressure is at rest. So we have here the equations given by Das Brahe MDAS o Facebook. So, this earth pressure coefficient is computed differently. Okay? Pag at rest, iba yung coefficient of lateral earth pressure natin. Pag active, iba din yung coefficient of lateral earth pressure natin. And then pag passive, iba din yung coefficient of lateral earth pressure natin. Okay? And we have here the diagrams for lateral earth pressure. So, kailangan nating mag-drawing ng lateral earth pressure distribution diagram to simplify our solution in solving our pressure, the active or the passive or our at rest pressure ng ating soil. So, if our soil is cohesionless with horizontal ground surface, so meron tayong horizontal and cohesionless yung soil natin, our pressure diagram is just triangle. So, pag ito yung ground surface natin, 0, and as our depth increases, mag-i-increase din yung ating pressure. So, the pressure here is equal to the coefficient of lateral earth pressure K times the unit weight of the soil times the height. And our resultant pressure, active man yan or passive, is equal to this value. The area of this triangle, which is equal to 1/2 K unit weight height times the height. Kasi i-multiply nyo din ito. Okay? So, our pressure here is equal to 1/2 K times unit weight times h squared. So, yan yung equation natin if we have this particular diagram. And if we have also a cohesion soil that is submerged, so pag sinabing submerged, meron tayong groundwater sa taas. So pag may groundwater tayo dyan, dalawa yung pressure diagram distribution na idodrawing natin dyan. One for the soil and one for the water since we have groundwater table. Okay, so for the soil, so, 0 pa rin dito sa ground surface at as the depth increases, mag-i-increase din yung pressure natin kasi meron na tayong soil. So, the same, our pressure is equal to K times unit weight times the height. This coefficient of lateral earth pressure depends on the condition of our soil, if it is at rest, passive, or active. So we have here the P plus we have to add the pressure caused by the water. So yung kukunin yung pressure dito, pag mayroon tayong groundwater, kasi ang given dyan is the unit weight saturated kasi nga meron tayong groundwater. However, dito sa ating pressure diagram, we need the effective unit weight pag nag-drawing na tayo ng pressure diagram sa soil. Kasi iba din yung pressure diagram ng water. So, we have here the pressure diagram of water. Meron tayong unit weight of water times H. Wala tayong coefficients since this is not a soil. Hindi soil ito. Okay? Hindi siya earth pressure. So, we just need to multiply unit weight times height. That is our pressure caused by the water. Okay? So, ito, effective, ito sa soil. And then, you have to add the pressure of water. So, yung P natin dito is we have to add the resultant of this diagram and this diagram. So, yung kalalabasan, itong equation. Next, we have partially submerged cohesionless soil naman tayo. So, pag partially submerged, merong part ng soil natin that is dry and merong part ng soil natin that is submerged doon sa ating groundwater table. So, yung ating pressure distribution diagram dito is that if we have here at the surface, 0. And as our depth increases, magkakaroon na tayo ng pressure dito that is equal to the coefficient doon sa dry, dito sa dry, and then yung unit weight dito sa dry times the height of this soil. And then, Pagdating mo kasi dito sa groundwater table, dalawang isosolve mo dyan. Either just above the groundwater table and yung just below the ground table. So, it depends. Pag nag-solve ka dito, pwedeng pabalik yung pressure mo or tataas yung pressure mo dito. Depends on the value of our K sub 2. So, meron tayo dapat dito. This is K sub 2. So, meron tayong either pa ganito na ang value natin is, so let's say meron tayong pa ganito na yung value natin dito, ganyan dapat yan. So, yung value natin dito is K sub 2 times the unit weight 1 K1. So, meron tayo dito K sub 2 unit 1 H1. So, dito at the groundwater, mag-iiba lang sila doon sa ating coefficient, K sub 1 and K sub 2, just above and just below our groundwater. Pero, yung pressure pa rin nito is the unit weight above and then yung height above kasi pag ganun yung distribution natin. And lastly, pag yung at height of H1, H2, ito yung magiging equation natin for our pressure diagram. And since yung ating pangalawa, yung partly na nasubmerge, meron tayong water, effective yung kukunin nating unit weight dito kasi iba din yung pressure diagram ng water. So, i-add natin yung pressure diagram ng water. So, wala tayong water dito sa taas. So, 0 yan. Wala siya. And then, dito lang tayo may water. So, the pressure of water is equal to unit weight of water times H2, yung height ng water. So, pag pinag-add mo yan, ang magiging pressure natin, active, passive, or at rest is equal to this equation. So, inad mo lang siya. Yan. Yung mga P1, P2, P3, and PW. Yan yung mga areas niyan. Resultant. Okay? And what if we have partially submerged cohesionless soil with surcharge? Ito naman, may uniform load tayo or yung tinatawag nating surcharge. The same pa rin yung dito sa dalawa, doon sa previous diagram natin. Ang inad lang natin is the effect of the surcharge. So, yung effect ng surcharge natin is actually the coefficient of lateral earth pressure multiplied by our surcharge. Yun yung value natin dito. Pag ginawan na natin siya ng pressure diagram. Okay? So, hindi na no need ito kasi this is just due to the surcharge. Wala tayong unit weight times height. You just need to multiply our surcharge multiplied by our K values. So, pag magkaiba yung K values dito sa taas and baba, magkaiba din yung i-multiply nyo dito. Okay? Paano naman pag meron tayong cohesive soil with horizontal backfill? Meron tayong active kasi meron tayong backfill. Meron tayong horizontal backfill. Okay, say we have here our soil. This is due to our soil. So, meron tayong cracking, yung depth of the, meron tayong tensile crack. So, pag may tensile crack tayo, na-minus natin yung value ng ating horizontal backfill, yung due to our crack, yung depth of the crack natin. So, ito yung original natin na pressure diagram. Ima-minus natin, this is actually this equation if we have cohesive soil. So, pag may cohesive soil tayo, either meron tayong tensile crack doon sa ating soil. Pag sinabi natin kasing cohesive soil, meron na tayong value ng C. And iba din yung pressure diagram pag meron tayong cohesive na soil. So, ito, ima-minus natin siya. So, ito yung original, tapos ima-minus natin siya, yung effect ng cohesive soil that will result to this diagram. Okay? So, yung depth of the tensile crack, yan yung magiging depth. Hanggang dito, may tensile crack tayo dito. And yung PA is given by this equation. So, you just have to subtract this equation with this equation para makuha natin ito. Okay? We also have here cohesive soil with horizontal backfill. Passive naman tayo. So, pag passive, we have to add yung effect ng ating cohesive soil. So, pag active, minus. Pag passive, i-add natin yung effect ng cohesive soil. Okay? So, yung pag-active, K sub P, itong mga to. K sub P, K sub P. So, that is the effect of our cohesive soil. Meron na kasi tayong value ng C. This is for the passive. You have to add. And then, you have to draw yung ating resultant na drawing din dito. So, that is the diagram for the pressure distribution.